Have you ever seen a plant in the most unlikely place? Like plants growing in an abandoned vehicle. You might wonder how these plants got there. These are the culprits. They carry pollen grains of flowers from one place to another. Wondering how this relates to dispersions and its measures? Let's take this plant for instance. Different bees carry its pollen grains to different locations. So, any species of this plant germinating around has a tendency to have grown from seeds of this plant. The pollen grains in the flower are the central tendencies, while the positions of the other pollen grains can be likened to the dispersions. In the same vein, dispersion in statistics is the spread of data values in a data distribution. There are various statistical measures of dispersion which include range, mean deviation, variance, and standard deviation. The range is the difference between the highest and lowest values in a distribution. It is calculated by subtracting the lowest value from the highest value of the data entries. The mean deviation is the dispersion of each of the data values x from the mean m. It is computed by subtracting the mean from each data value. Interestingly, the sum of the mean deviations is always 0. This is why we use the summation of the absolute values of each deviation divided by the total frequency to compute the mean absolute deviation. The average of the square of each deviation from the mean gives the variance. Finally, the square root of the variance is the standard deviation. The standard deviation is a measure of the amount of variation or dispersion of a set of values from the mean, and it is the most important measure of dispersion. In this lesson, we have learned that dispersion is simply the spread of data entries in a data distribution. The measures of dispersion are range, mean deviation, variance, and standard deviation.